In this orthokeratology case, the patient has worn lenses for about 6 weeks, but is still undercorrected, and there's also some lack of completeness of the treatment ring here. There's not as much distinction of steepening underneath the reverse curve here, and then also in the left eye. So for the right eye, what I would do to tackle a case like this normally is to steepen the periphery of the lens, give the lens a little bit more sag so it bears down more peripherally. Also here I would flatten out this curve so it lands a little bit sooner on the cornea, and then also finally add in the increased tilde demand to take care of the undercorrection. So I'm going to do the undercorrection first. It was 3/4 of a diopter remaining minus after lens wear. So our new target, if we add that in, will be 1.93. So I'm just going to pop up here until we're as close to 193 as possible. And looks like that one's going to be closest. That was in 100% mode. I noticed we are designing in freeform. As a side note, on a cornea like this, I would normally do a G-SYM lens. I think it would work pretty well. There is a little bit of asymmetry, but not so much that I would think a freeform lens is necessary. And sometimes when we start with a freeform lens, future troubleshooting is a little bit more tricky. But since that's where we are, that's where I'm going to leave it. I've increased the power, but I do need to go to 25% mode. And I'm going to run through every meridian to make sure we are as close to 193 as we can be. So that's pretty good there. We might be able to get closer there. Okay. And okay, our new power is set. Next thing I'm going to do is switch back to 100%. And then I am going to drop the blue ball down and give us some more bearing peripherally. 4 clicks is usually about 5 microns, which I think is a really good starting point. I'm also going to lift the pink dot a little bit so that the lens drops and lands on the cornea a little bit sooner. That did decrease our lift a little bit. So I'm going to go one more. So right now we're at 6.4 microns of clearance. I'm going to pull up an original lens here. The original was at 1.7. So we're just a little bit under 5 microns total of change. You can see our original lens sag was 2099. Our new one is 2102. So we do have a little bit more sag in this lens. It's a taller lens, and it should bear down and tighten up this area of your topography. So I'm going to pause the video, and we'll bring up the left eye. And now we have up the most recent design for the left eye. When I look at the post-wear topography, I notice that the treatment zone is slightly oval here, and the patient indeed does have a cylinder component to the post-wear refraction. It's -2, -1.25 at an axis of 18. And if you look at the spectacle refraction, there's not much cylinder there. It's mostly a spherical RX. And so whenever I see that, I kind of wonder, well, where's this cylinder coming from? And a couple tips that or tools that I would use is first to have the patient put the lens on and do refraction over the lens. If that refraction is largely spherical, then that tells me something about wearing the lens is inducing this cylinder. Another thing that I would do is look at the fluorescein with the lens on, and it's possible that you'll see a little bit more edge lift, superior or inferior, or maybe even a little bit more pooling in the mid-periphery, superior and inferior, which indicates the lens is a little bit loose in this meridian and possibly rocking up and down across a fulcrum going in this direction, which would induce a little bit of cylinder. So If that's the case, then I would steepen the lens only in this vertical meridian. We get more bearing superiorly and inferiorly. And then also we need to take care of the undercorrection of 2 diopters. So let's do that first. We're starting at 129, so our new target is going to be 329. So we're going to have to click up quite a few times here. And we're there. Again, we're in freeform in a cornea like this. I think GSOM would be okay, but I'm going to leave it as it is. And then I'm going to go to 25% mode, and we'll go through each meridian, make sure we're at 329. We're a little bit off here. Let's be closer. Okay, so the power looks good. And then I'm going to switch to 50% mode, and we're only going to steepen the periphery in this meridian. We're starting with clearance of 3.0, so at most we'll want to bump that to an 8, at least for a starting point. So 7.8. And then I do have to go to the bottom because we're in freeform and do the same thing here. If this were a GSOM lens, you would only have to do it either in the superior or the inferior meridian, and it would, by nature, be duplicated down below. All right, and then the last thing I'll do is, again, back in 25% mode, go around and make sure the curve is nice and smooth in every meridian. Okay, there is a little bit of a kink there that we want to get rid of. And this is kind of a trial and error type of scenario. You just have to find what's the smallest change you can make to this lens to get back to this normal curve. And looks like that is it. So we have the lens, it's going to bear down a little bit more in the vertical meridian. We've increased the topo demand to take care of the undercorrection. I think the adjustment to the fit of the periphery of the lens will take care of the cylindrical portion of the OR. And then the topo demand to take care of the spherical portion of the OR. So that's the right and left lens. Hope this is helpful, and thanks for watching.